Hello everyone, welcome to our last day of notes for Unit 5. Today we're going to be doing systems of inequalities, so very similar to just graphing linear inequalities, but now we just have more than one, so let's do a quick review. So when you're graphing inequalities, you got to do 4 steps. You got to first put it in slope-intercept form, y equals mx plus b. Then you're going to have to graph those lines on the coordinate plane. Now, once you graph the lines, you either need to make it dashed or solid, depending on the inequality sign, or shade above or below, depending on the inequality sign. And for the actual line, if we're going to make it dashed or solid, a solid line would have the inequalities of either less than or equal to or greater than or equal to. A dashed line would have less than or greater than. For shading, you're going to shade above when it's greater than or equal to, and you're going to shade below when it's less than or equal to. This is all a review from the other day of notes. Okay? So some vocab. A system of inequalities is just a group of 2 or more linear inequalities. A solution of a system of inequalities is the ordered pairs that are in the double shaded region. Those are the ones that are going to make both inequalities true. So not only are you going to have to shade both of them, but then you're just going to look for the twice shaded part. So it's usually the darker part, whatever you use. Okay? So example 1, we're going to find the solutions to this. Oh, dear. Interesting. Well, my graph looks weird because the stuff I put on it. Ignore it. Okay? So, first I need to get these both into slope-intercept form. The bottom one already is, top one is not. And what I like to do to help me is to figure out, to color code them. So I'm going to say that one's going to be blue and this one's going to be green. That way I can just keep it straight. You don't have to. It's not going to hurt you if you don't. I just like to, so it helps deconfuse me. Alright, so this first one I need to change. So I'm going to first write it over to the side, and then I'm going to subtract 2x from both sides. So now I have, there we go. Negative y is less than or equal to negative 2x minus 4. Then I'm going to divide everything by negative 1. Now because I'm dividing by a negative, I will need to flip my sign. So it becomes y is greater than or equal to 2x plus 4. Okay? Now I'm going to graph my 2 lines. So this one is going to be a solid line because it's an equal to, where the green line will not be solid. Okay? So first I'm going to start on my y-intercept, which is right here. Oop, there. Ignore it. Right there. And then I'm going to go up to and over 1, which will plot my next point. And then I'll draw my line. I will draw my line. Wow, I can't talk. Okay? And because it's greater than, I am shading above. It's all in different parts, though, because I did a horrible job shading. Okay, so that's my first inequality. Now I need to do the green one, the second one. So I start with my y-intercept is at 1. I plot that point. Then I'm going to go down 2 and over 3 to plot my next point. And now I draw my line, which is not going to be solid because I'm not equal to. And there you go. To shade it, I'm going to shade below this line because that's what less than means, I guess. This is the graph. It looks kind of messy because of the color choices I made, but oh well. I also got the hiccups right now, which is so much fun. But do you see this darker section? This is the section where both the blue and the green have solutions. So this is the section that have my solutions to the system. Okay, all these ordered pairs in this darker section are solutions to my system. Okay, and I wrote that somewhere, I think down here. So my solutions are right here. Okay, you guys just need to make sure that when you do these on a test or something, that this is really dark, so I know that's where your solutions are. Okay, next one. You guys are trying this one on your own. And then we're going to do this one where you can kind of see. So this one was just asking me to write the system of inequalities. Again, I like to color code it. That's really all I did on the graph. So this dotted one I made my yellow, the solid one I made my purple, and I just worked with it by color to help keep it straight. So for the dotted one, I noticed it had a y-intercept of -4. It had a slope of 2 over 1, so I went up 2 over 1 to get my next point. So that means it has a slope of 2. I noticed it was dashed, and it was shaded above. That's what this gray part. So they won't always shade everything. Sometimes on the graphs they'll only shade the double shaded part, but you can still tell if it's above or below the line. Even if it's only half the line, it's above. Okay? Knowing all that, I can put my slope-intercept together. It's going to be y, and because it's dashed and shaded above, it's greater than or equal to 2x minus 4. Okay? And then I did it for my purple. The y-intercept here is -1. The slope is actually 1 over 2, so it's 1/2. It is solid, and it's shaded below the line down here. Okay? So that means I'm going to have y is less than or equal to, because it's solid, it's the equal to part, shaded below means less than, 1/2 x minus 1. So then I just write it as my system, and those are my two inequalities that make this system on the graph. Okay? Try this one on your own now. Remember, the shaded part is that double shaded part. Okay? Now this last page, I realized, is not the best way to do this. Some of these are really, really big numbers for both the example and the try on your own. At the very least, if you're having trouble graphing because they're too big of numbers, I understand. At the very least, though, to make sure you guys get full credit for this, I should see a system for it. You should be able to write the system. Okay? That's my tidbit. Alright, so this one, I still tried to do it anyway, which means you guys can still try, and we're going to go with it. So, just like writing systems of equations, they give you all the information to write the two inequalities you need. Okay? So I first went through it, I read it, and I just underlined stuff that seemed important. So you can work at most 25 hours. Remember, at most should be the clue that that's going to be the inequality. Okay? At most 25 hours next week, you need to earn at least $85. Again, that's another inequality. So those are basically our two totals, 25 hours and 85 hours to cover your expenses. Your babysitting job, so one thing that's happening is babysitting job pays $7.50 per hour, and your math tutoring job pays $6 an hour. Write a system of linear inequalities to model a situation and then solve. Okay, so I know that I'm going to be at most $25 and at least, or 25 hours and at least 85. Okay, dollars. So those are my two totals, and I have the inequalities to go with it. Okay, the hours are going to be made up of babysitting and math tutoring. All right, while the money will be made up of the hours the money you make at each job. Okay, so I first came up with my variables. I said y is tutoring and x is babysitting. Okay, so to make up the 25 hours, you'll do x plus y, and at most means has to be less than or equal to 25. Then the 75 or 750 per hour, so x is your babysitting hours, so $7.50 per hour for babysitting, plus the $6 you make per hour for the tutoring, needs to be at least means greater than or equal to the $85. Those are your two inequalities. Okay? And that's how you have to set it up. Now, to be very honest with these kind of questions, a lot of the time it's multiple choice, and it's all like different parts of the graph are shaded. So worst case scenario, you could always pick a point and test it out to see if it satisfies both. Okay? Worst case scenario. But I wanted to show you an example anyway. So now I need to graph this. In order to graph them, I need it in slope-intercept form. So that's what I did first. I changed it to slope-intercept. Here I subtracted x from both sides. I got y is now less than or equal to negative x plus 25. And then that's what I'm going to graph. And then for the green one, I first subtracted 7.5x from both sides. Then I have 6y is greater than or equal to negative 7.5x plus 85. Divided everything by 6. Y equals negative 5/4. I changed this to a fraction just so I could graph the slope. And then I made this a decimal just so I can find my y-intercept rather than deal with a fraction for it. That's the only reason. So to graph these, because my graph was too small, I decided to count by 5s. Everything. So 25 would actually be 2.5 right here. And then I would be going down 1 over 1, down 1 over 1 the whole time. Which, why is this green? It's supposed to be blue. There you go. There's my blue. And then I shaded below because it's less than or equal to. Here, I graphed it at 14 point. You know what, guys? This one, we're going to ignore this one because it's a bad example. I'll give you a better example in class. But basically what happened is this little overlap right here, those were where my solutions were, which was not a lot, but I could find them so I could figure out how many hours I can work. So try this one on your own. At least try writing the system of inequalities, and then we will go over a better example of this in class. Okay, so that's all I got for you. If you have questions, write them down, and I will see you next class. Bye. Fine.